So now that we know some of the properties of the normal distribution, we're going to find some areas here. Areas will correspond again to probabilities and also to proportion of the data. So for example, here's our normal distribution curve, and we want to compute the area between z equals 0 and z equals 1.32. So remember, z equals 0 is always at the middle of the distribution, and then this is z equals 1, 2, 3, negative 1, negative 2, negative 3. It's always a scale of 1 unit when you're talking about z-scores. So this 1.32, that's going to be, about right here, between 1 and 2. And so we are trying to find this area underneath the bell-shaped curve. So, and we're going to use technology to do this. Many times books will use tables to compute these values, but technology is definitely a better choice here. So on your TI-84, you want to go to the distribution menu, second variables, and then you want choice 2, normal CDF. So the CDF, normals for the normal distribution. I'm going to press number 2, and CDF is cumulative distribution function. So it's accumulating the area. So you have to enter in a lower and an upper cutoff, and then for z-scores, mean and standard deviation are always 0 and 1. So this negative 1 e to the 99 is scientific notation for a big negative number, and that's the default. Let's just clear that out. We want between 0 and 1.32. So our lower cutoff is going to be 0. Our upper cutoff 1.32. We don't have to do anything with the 0 and 1, so we'll arrow down and paste. And we get a value of, pressing enter again, 0.4066 to 4 decimal places. So this is 0.4066. And what we did there was we did normal CDF, and then it was 0 to 1.32. So what we're doing is normal CDF, lower bound and upper bound. You don't have to specify the 0 and 1 for z-scores. Let's try another one here. Compute the area to the right of z equals 2.01. So again, 0 in the middle, 1, 2. So the area to the right of 2.01 is right here, that little sliver of area. So we're also going to do normal CDF. And our lower cutoff is going to be 2.01. And our upper bound or upper cutoff, well, this actually goes out to infinity here. But we'll just put in a large positive number. So like 10,000 should be enough. And let's go ahead and compute that. So second variables, option 2 for normal CDF. Now our lower is going to be 2.01, and our upper 10,000. And now we can paste and enter 0.222. So 0.0222. So this little piece of area is 0.0222 or 2.22%, the whole being 100%. So about 2% of the area in here, about 41% in here. Next, they're asking us compute a probability. Remember that uppercase P stands for probability. So they want us to compute the probability that a randomly selected z-score would be less than 1.78. So z equals 0 would be here in the middle, 1, 2, 1.78 would be about right there. And the probability that z is less than 1.78 is going to be corresponding to area. It's the area to the left of z equals 1.78. So that's going to be all this area here. Well, here I can actually dump some color in there. So that's going to be that yellow area. And with the normal CDF function, we want our lower and upper bound. Well, our lower bound, this tail of the distribution actually goes out to minus infinity, but we'll just use a big negative number, like negative 10,000. And some books will use negative 1e99. So that's scientific notation for negative 1 times 10 to the 99th power. We can just use a big negative number like negative 10,000. And then our right cutoff, 1.78. Let's go ahead and key that in. So second variables, normal CDF, lower negative 10,000. Well, I got a couple extra zeros there, doesn't matter. Big negative number. Our upper, 1.78. And we will paste and enter. 9625 to 4 decimal places. So 0.9625 is that area, 96% of the area, but that also means if you pick any random data value, its z-score will be less than 1.78 96% of the time. And now compute the area to the left of z equals negative 1.54. So z equals 0 here in the middle, negative 1, negative 2, negative 3, so negative 1.54 about right here. And we want to the left, so we want that little piece of area. So our lower cutoff is going to be negative infinity again. So this is going to be normal CDF. And our lower cutoff, pick a big negative number like negative 10,000. And our right cutoff or upper bound, negative 1.54. Go ahead and key that in. So second variables, normal CDF. We'll go ahead and keep that lower bound, and then we want negative 1.54. Paste and enter. So 0618 to 4 decimal places. So this area is 0.0618. And that is the area to the left of negative 1.54. It's also the probability that z is less than negative 1.54. And it is also the proportion of the data that's to the left of z equals negative 1.54.